This is just another video for phase equilibrium diagrams, and on this video I want to discuss the liquid component of a binary system that has a vapor and a liquid. So we'll be discussing this area. So we'll be in that area. And what controls the composition of the liquid and the vapor is actually the temperature. So even though we may have a system that's at 0.5, the liquid or the vapor wouldn't be 0.5 moles of A and 0.5 moles of B, or mole fractions of A, mole fractions of B. So at around 200 degrees Fahrenheit or whatever, 200 degrees Fahrenheit, it can actually only have one type of concentration of A and B, and that is at the saturated liquid line. It will always be around 0.25 mole fractions of A and 0.35 mole fractions of B, 75 mole fractions of B. And that's only when there is a vapor-liquid equilibrium. So if you change the mole fraction of the entire system between 0.25 and 0.75, if the liquid and vapor are in equilibrium, the liquid will always have 0.25 mole fractions of A, and the vapor will be 0.75 mole fractions of A. And that's when the system is at 200 degrees Fahrenheit for this made up system. Once you go past this 0.25 mole fractions for the entire system, so let's say we have 0.2 moles of A and 0.8 moles of A, then we're in this liquid area, just this pure liquid. And when it's pure liquid, it will be just the entire system, because the entire system is a liquid, so it will be 0.2 moles of A and 0.8 moles of B. But when you're at 200 degrees and you have a liquid phase that is between 0.25 and 0.75 mole fractions of A, the liquid will always have a mole fraction of 0.25, and the vapor will always have a mole fraction of 0.75 of A. So I guess I can write that down. So mole fraction of liquid, mole fraction of A, liquid mole fraction will always be 0.25 between when you have a system that is at 200 degrees, and the entire system's mole fraction is between 0.25 and 0.75. The vapor, and just go mole fraction of A, will always be 0.75 at 200 degrees when the entire system's mole fraction is between 0.25 and 0.75. So that's the basic. And the other thing I want to talk about is when you have a mole fraction that is 0, this is actually the boiling point of B, and this is the boiling point of A, or BP of A, because that's pure substance. Whatever the compound is, it's pure that. It's just completely that. So then it's just the boiling point. And notice the boiling point changes from it goes from high to low, or low to high. It can actually go this way, but that's kind of off the subject. So that's all I really want to discuss. Is that, again, I mean, that's kind of a hard thing. So if you have a if you have a system that has, instead of, you have 0.3 moles of A and 0.7 moles of B, and this could actually be 30 moles and 70 moles, then your mole fraction for the entire system is 0.03 of A, and if it's the system's at 200 degrees, then again its liquid will be 0.25 mole fractions of A. So depending on the volume or whatever, so I might be overdoing this. But the next video I'll go over just comparing this spot to this spot, and that's a bit confusing at first, but something to look forward to.